Hey guys, this is Carrie, and in this video we're going to be continuing Lesson 6 and looking at problems 3 and 4 where we use our Caesar cipher to decrypt and encrypt things. So, picking up where we left off, let's save our new file to be problem3.html. Now for problem 3, probably the easiest way to generate everything is to copy and paste the original one here. We're not going to be needing probably any of these functions, so I'm going to start by deleting all these functions. We are going to need the alphabet though. So let's think. If we're going to use the Caesar cipher to encrypt something, it's a little more complicated than what we were doing before, so it pays to understand it. So let's say we're using a Caesar cipher with a shift of 1. What that would do is it would turn A into B, because it shifts each one by 1. If we were doing a shift with 2, it would turn A into shifting it to C. Now where things get complicated is with the end of the alphabet. So if we were doing a Caesar cipher with shift 2, what that would do is it would take Z and it would shift it twice, looping back around from A to B, so Z would become B. Okay, so now that we've got that all taken care of, the understanding of it, let's see if we can program this algorithm. So we're going to create a function, and let's call it encrypt letter. Because if we're going to go through and we're going to encrypt entire words, we definitely want to be able to encrypt it letter by letter. So this is going to take in a letter, and it's also going to take in a shift amount, which is how much we're shifting by. So let's think about how this might work. I'm going to open this up in the browser, and let's see. All right, so let's let made up, this is just going to be something random that I make up here. It's going to have a couple of characters in it. So let's see, H, Z, P, and I'm doing the first comma so that the indexes match what we would expect. I know that looks strange, but we need that. So now if we do made up 2, it should be giving us Z because that's the second element in our list, and it does. Now the question that we're going to have to answer is kind of the backwards of that. Let's say that we know we want to find Z in our list. How can we start with Z and then figure out that it's at the second index? And there's a built-in function in JavaScript called index_of. And what index_of will do is it will tell us where this element appears in our list. So Z appears in the second spot. P appears in the third spot. And that's going to be really important because what we're going to have to do is we're going to have to figure out where our letter appears in the alphabet. Okay, so I think we're ready to encrypt some letters. So let current position or current index equal, go into the alphabet function and find the index of whatever letter, not the word letter, whatever letter was inputted into the function as a parameter. So if they want to encrypt B, then it should find the index of B to be 2. Now in order to get the next one, what we really want to do is we want to shift that index so that if we're looking at 2, it becomes, let's say the shift is 2, it becomes adding 2, 4. If we're looking at 3, then it shifts it by 2 and we're going to look at index 5. So in order to do that, let new index equal the current index plus whatever the shift is. So let's console.log whatever the new index is. And let's also console.log whatever the current index is, just so we can see what's going on in our function. So saving it and refreshing it, deleting this stuff down here. If we try to encrypt a letter, and that letter, let's say, is A, and we want to shift it by 1, it gives us that A was at position 1, and now we're shifting it to position 2. If we want to encrypt the letter C, and we want to shift it by 4, let's see, 3, yeah, is going to become 7, which would be G. So that looks like pretty good so far. Now, the place where we're going to run into a problem, as you might imagine, is with the end of the alphabet. So if we want to take Z and shift it by 1, Z is currently at position 26. The new index is going to be position 27, and there is no position 27 there. So in order to prevent this from happening, we need to say if the new index is greater than 26, then the new index should equal whatever the new index was minus 26. And so what this will do is it will re-loop it back around because we're subtracting 26 from it. So in the example of z, we shift z from 26 to 27. If we subtract 26, it will go back to 1, so z will go back to a. With our new definition, let's see how this works with z and 1. So 26 gets shifted to 1. If we're doing a shift by 3, then 26 would have been shifted to 29, but we want it to end up at 3, which will be c. Shifting y should leave us with 2, which will be b in the end. And that works. 25 gets shifted to 2 now because we're subtracting off that extra 26. All right, so these console.logs work. Now, what we really want to do is we want to get the new letter. So the new letter is going to equal, or sorry, let new letter equal, because this is the first time we're declaring it. Let new letter equal the alphabet, the value from alphabet located at whatever the new index is. And then we're going to return the new letter out from the function. So this function encrypts letter by letter, one letter at a time. We want a function that encrypts an entire message. So let's define a function called encrypt message. Now, to encrypt a message, we need to take in what the message is and also what the shift value is. So the first thing that we're going to do when we encrypt a message is we're going to take that message and we're going to split it up very similarly to how we did with the previous encryption method into a list of the letters used to compose it. So hello, or sorry, let's just do hi. Hi, we want to split and make it into the list hi. And then we can go through it letter by letter for each letter and shift each letter one at a time. So in order to split each of these, we'll do let message list equal whatever the message was dot split on the empty character, which will split it for every character. Then we're going to say take that message list, which is now just a list of letters like H and I right here, and go through it. And for each of these letters, we want to do something. We want to basically encrypt that letter and then add it to the encrypted message. So we actually need to start by having an empty encrypted message that we're going to build up letter by letter. So we'll start with the encrypted message equal to a blank message. So now as we go through this, for each letter, we want to let the new letter that we're going to add equal the result of encrypting the letter. So we'll encrypt it. Oh, not encrypted message. Encrypt a single letter. And we're going to encrypt whatever letter we're currently up to. So letter works here. And then for shift, whatever the shift was that they plugged in here. Now the next thing we need to do is we need to say encrypted message equals the old encrypted message, which starts as nothing, plus whatever the new letter was. Finally, when we're done with all this, we should display, and just the for each loop is super powerful here. It's going to encrypt everything letter by letter, and it's going to get all of them because it's doing it for each of them. So now we display whatever the encrypted message was. And we'll return, in case we want it somewhere else, whatever the encrypted message is. So let's do a trial. Let's encrypt the message. Let's encrypt the message hello with a shift of 1. So H should shift to I. E should shift by 1 to F. Let's see if it works. Yep, L shifts by 1 to M. L shifts by 1 to M. O shifts by 1 to P. And things are looking pretty good. Now, we want to probably check to see that it works for things like zoo with the letter Z in them. So let's give it a save. So zoo, Z should shift by 1 to A, and then O should become P and P. So it becomes app. That's really interesting. Zoo becomes app. And if we shift it by 2, we should get B, Q, Q. So that's working as well. I think we've got our encryption method completely set. For our decryption method, it's going to be very similar to this one. So let's create a new file, problem4.html. So to decrypt something, let's just copy and paste all of problem 3. So we're going to save this And this one, we don't want to delete everything that we're thinking about. Basically, when you decrypt here, it's very similar to encrypting. So anywhere where we see the phrase encrypt, we're going to change it to decrypt. So let's decrypt a letter. So the current index is going to be the index of the encrypted letter. So if we're encrypting and we go forward to, when we decrypt, we should go backwards to. So it looks like the new index will be whatever the current index was minus the shift, because we're going to go back, shift back to -2 or -3, whatever the shift value is. Now, because we're subtracting, we won't have to worry with ending up with a index value that's bigger than 26, because we're not adding to it. The only thing we're going to have to worry about is we may end up subtracting, like starting at A and subtracting 2, and then we end up in the negatives. That could be a big problem for us. So to avoid having a problem with the negatives, let's see, to avoid having a problem with the negatives, what we should do is we should say if the new index is less than 0, if it's negative, then we want the new index to be whatever the new index was plus 26. And then we'll return the new letter. All right, so now we need to decrypt our message. So let message list equal message.split. And that makes sense. We still want to split it. Let decrypted message now equal an empty string. Message list dot for each letter. Let new letter equal decrypt letter. And we're going to decrypt that letter using the shift that's plugged in. Now our decrypted message becomes whatever the decrypted message was plus the new letter. And then we're going to display the decrypted message here and here. Okay, so let's open up this one in our browser. So let's start by decrypting app. And we saw that when we decrypt app was actually zoo, so we're going to decrypt it by 1, and that should give us zoo, but we're getting an error. Okay, so let's go to our JavaScript console. Encrypt message is not defined. Oh, down here. We're not calling the encrypt message function anymore, we're calling the decrypt message. So if we decrypt app, we get undefined 1. If new index, is less than, not 0, it should have been less than 1 because A is at 1, so we can't have 0. So that gives us zoo. All right, if we try it for hello, let's see what happens with that. So the easiest way is to work with these in pairs. So let's start by encrypting hello by 4. So save that, refresh it. Okay, 4 is weird. Let's encrypt it by 5. Okay, so 5, we can copy that. Now we go to our decrypt algorithm, and we're going to decrypt it by 5. And let's see if that gives us the right thing back. So we go to problem 4 over here, and we refresh it. And yes, that gives us hello from Magict, which was our encrypted version. All right, so we've got a nice pair of functions. Now, there is something important about these functions. I don't know that they work when you have non-alphabetical characters. So if we try to encrypt something like hello world with a space, let's see how that does. So hello world with a space runs into a bit of a problem where it actually messes up and has the letter there. So that was a bit of a mistake, and maybe we should figure that out another time.